Today I would like to discuss the problem solving involving the rate of changes. This is a very challenging topic. So let's get started with the class. So let's read the question carefully. Let's see the example. You can see there is an inverted cone with a base given and the height given, right? So now we are going to solve this problem. So let's write down the formula for the cone. V is 1/3 pi r square h, and then the water leaks out from a small hole. When there is a leak out, means the volume will decrease. So we have to put the sign of negative when there is a decreases in terms of volume of water. So we are asking to find the rate of change of the depth of water in the cone when the height of water is 3 centimeter. So first of all, rate of change of depth of water, what is that? So, and the height of water is 3 centimeter. Now, the rate of change of the depth we will write as dH dt, and the height of water is 3 centimeter. Alright? So we are asking to find the dH dt. Now let's try to differentiate the volume with respect to h. Okay, before that, the dH dt we must write in terms of the change rule with the dH on top and dt below. And we have one more unknown that will be volume. Volume is change, so we will write dV for both of the term. So we have dH dV multiplied by dV dH. So it means that we have to find dH dV. So now we go back to the volume formula. Normally we will just differentiate the h, okay, with respect to the volume. So in this case, the radius have to express in terms of the ratio of the h. That means radius ratio to h should be equal to the radius original is 5. We will find the ratio so that we can find the relationship between the radius and the height. So radius is 5 and the height of the cone is 12. This is an important point that you must remember. So you have to find the ratio of the r over h. Then you have to express r in terms of the h. That means r is 5 over 12h, and you need to square it, right? So if you square the 5h, you will get 25, right? 25 h square, you have to times the h, so it becomes h cubed, right? So the pi is up, and the 12 square you have to times with the 3. Alright, so the volume in terms of the h, so you need to differentiate the volume with respect to h, which is dV dH. And after we differentiate, we have to substitute the h equal to 3 into the dV dH, and actually we can express dV dH as a number, right? So now we will write dH dt equal to dH over dV times the dV over dt, and we need to inverse our dV dH because we are having dH dV, so it's 1 over dV dH. You understand? Because our chain rule, we don't have dV dH, we are having dH dV. But when we differentiate, we have dV dH. So it's 1 over 4.90 94, and then we need to times with the dv dt, which was given earlier in the question, which was -4. So finally we just simplify -4 divided by 4.9094, and DHTT is -0.8148 centimeter per second, which is also decreased, right? Alright, let's proceed to next example. The radius of a spherical balloon filled with air increases at a rate of 0.5 centimeter per second. Find the rate of change of its volume when the radius is 4 centimeter. Correct to 4 significant figures. So we are asking to find the rate of change of volume when radius is 4 centimeter, and the radius of a spherical balloon. So spherical, we have to write down the formula so that we can have a relationship between volume and radius. And we are also given the rate of the increases. Okay, increases at the rate of the radius is 0.5 centimeter per second, and then we're asking to find the rate of change of volume, which is dv dt at the radius equal to 4 centimeter, right? Okay, then we are going to start with the formula, because the formula will show the relationship between volume and the radius. So from the volume formula, we will differentiate later on. So we are asking to find the rate of change of volume. So we write dv dt equal to dv dr times dr over dt. So we need to differentiate the volume with respect to r, which is 3 times 4 over 3 pi r square, which is 4 pi r square, right? And the dr dt was given earlier, we just multiply. So it's 4 pi r square times 0.5. So the radius was given 4 centimeter. So it's 4 times pi times 4 square times 0.5, and we will get the answer for the dv dt, right? So dv dt is 100.5 cubic centimeter per second. Alright, so let's proceed to another example. The diagram on the right shows a bit moving along a curve with the equation y equal to 1 over 8x squared. At point A42, the rate of change of x is 3 units per second. Find the rate of change of the corresponding y. So let's highlight the important keywords is the rate of change of x is 3 units per second. So it means dx dt is 3 units per second. So we are going to highlight what is asking to find. Rate of change of the corresponding y. That means we are asking to find dy dt, which is actually equal to dy times over dt. So we are going to plug in another unknown, which is dx. So dy dx times dx dt. So in this case, we have to find the dy dx. So from the y equal to 1 over 8x squared, we will differentiate. We will get 2 times 1 over 8 times x, which is 1 over 4x, and we times with the 3, right? So we will substitute the value of x, and then we will solve. The value of x is what given at the point A, 4, right? The x is 4. So 1 over 4 times 4 times 3. So the answer is 3 units per second. Now I'm going to share with you how to solve the Hodge question. So let's get started with the exercise given here. The area of a square with side x increases at a rate of 8 centimeter square per second. Find the rate of change of each side when the area is 4 centimeters square. So this is actually a question that involving thinking skills. So area of a square with a side x increase at the rate of 8 centimeters square per second. That means dA dt is 8 centimeters square per second. So now you have to actually focus to the keywords. Find the rate of change of each side when the area is 4 centimeter. That means dx dt at the area equal to 4, but the square, you should know, the square is x times x, right? So it's equal to 4. That means indirectly the question is telling you find the rate of change of side when x equal to 2, right? X squared equal to 4, that means x is equal to 2. So we find the x equal to 2, then we are going to use the chain rule. So the chain rule is according to dx dt equal to dx on top, dt at the bottom, and is actually changed by the dA. So we are going to substitute 1 over dA dx times with the dA dt. So it's actually 1 over 8. Alright. So times with the 8, because the dA dt is actually 8. Alright, so dx dt is equal to dx dA times dA dt. Okay, so we are going to substitute with the 2x, because the dA dx is actually equal to 2x, right? So because area is x squared, so dA dx is 2x. So we are going to solve the answer 8 over 2x. So the answer is 2, right? It's 8 over 4. For question number 3, a block of ice in the form of a cube with side x is left to melt at a rate of 10.5 cubic centimeter per minute. Find the rate of change of x when x is equal to 10. So what are the keywords? The keywords are ice in the form of a cube, side x, okay, melt, it means the volume will decrease, rate is 10.5 cubic centimeter per minute. So because of the melt, we knew that its volume is decreased, so we need to put negative. Alright, so we have dV dt equal to negative 10.5 cubic centimeter per minute. So beware, there is a negative because the volume is decreasing due to the ice is melting. So the word melt means volume decrease. Okay, so remember that. Find the rate of change of x. Rate of change of x meaning that dx dt. So at the x equal to 10 centimeter, right? So now we are going to write the relationship between the volume and the x, right? So before that, let's write the chain rule, dx dt equal to dx dv times dv dt. So the dv dt is negative 0.5, and the dx dv, we have to differentiate dv dx, which is 3x squared, right? Okay, but then we are having dx dv, so we have to inverse the dv dx. dx dt is 1 over dv dx times negative 10.5. Okay, so dv dx is 3x squared. So meaning that dx dt is equal to 1 over 3x squared, right? okay, times negative 10.5. It also means that negative 10.5 divided by the 3x squared, right? When we differentiate, it becomes 3x squared. So we need to substitute the values of x, which is 10. So the dx dt is 10.5 divided by negative, okay, 3 times 10 power 2. So the answer you can give in fraction. Beware that there is a negative, because when the volume decrease, obviously the size also will decrease, right? Okay, so let's proceed to the next one. For question number 4, looks very interesting. You can see there is a candle. The diagram on the right shows a cylindrical candle with radius 3 cm. Cylinder with the radius 3 cm. The height is h centimeter and its volume is V. So we write the formula for volume V equal to pi r square h. And then the h was not given, but the radius was given. So we can substitute the radius. So it becomes 9 pi h. So that means volume equal to 9 pi h. So we are going to differentiate later. So the candle is lit and the height decreases at a rate of 0.6 centimeter per minute. So it means that dh dt is equal to negative because of the height decrease, right? Okay, 0.6 centimeter per minute. So we are going to find the rate of change of volume, okay, which is dV dt, right? Rate of change of volume, okay, of the candle. So dV dt is equal to dV over dh times dh over dt. And then we will differentiate the dV dh, which is 9 pi. So in order to find dV dt, we will take 9 pi times negative 0.6. So the answer will be negative 5.4 pi cubic centimeter per minute, right? So if we solve it, we will get the answer negative 5.4 pi. Don't forget there is a pi for the answer, and the answer is negative, right? Because the volume is decreasing, okay? The dV dH equal to 9 pi is telling us that actually the rate of change of the volume is actually not affected by the height. It's actually a constant. dV dH is 9 pi. Alright, so there is nothing to do with the height. When we differentiate, we would get dV dH just 9 pi. Right, so the answer for the rate of change of the volume is negative because the height is decreased, the volume will decrease. Okay, so let's go to the last question. Chandran walks at a rate of 3.5 meter per second away from a lamp post one night as shown in the diagram on the right. The height of Chandran and the lamp post are 1.8 meter and 6 meter respectively. So the keywords is Chandran walks at a rate of 3.5 meter per second away from a lamp post. Just label like this, okay, x. So the dx dt is 3.5 meter per second. So we are going to label and work on the diagram. So the s is actually the distance for Mr. Chandran. Okay, the rate of change of the length of Chandran's shadow. So the shadow, the distance of the length of the shadow we use s. So that means we need to find the relationship between the x and the s. So 6 over x, you can draw a triangle. The height is 6. The base of the triangle is x plus s. And there's another small triangle. The height of the Chandran is 1.8 over the s. So you can draw two right angle triangle, and you can find the relationship between the s and the x, because whenever we want to differentiate, we must have the relationship between the x and the s. Okay, the relationship is actually an equation, right, between the s and the x. So because we don't have any formula here, so we have to come out with the relationship by using ratio. So that means the s is 3 over 7x. Then only we can solve the other part of the question. So the ds dt is given by ds over dx times dx over dt. So we are asking to find the ds dt. So in this case, we need to differentiate the ds over dx, which is 3 over 7. That means the s change with the x by the constant 3 over 7, and the dx dt was given 3.5. So that means the rate of change of the Chandran's shadow is actually 1.5 meter per second, right? Okay, so let's solve the part B. Okay, for the part B, so we need to work out the length. Okay, we call as L. Alright, so this is the L. Tip. Okay, moving tip L. So we just label moving tip L is actually the measurement from the lamp post to the end, right? So this is so-called moving tip is equal to the length of x plus the s, right? So this question is a bit challenging, right? So now we need to actually write down, okay, the L is actually x plus s. So the s is 3 over 7x. So that means we can write down L in terms of the x. So if you add, it should be 10 over 7x, right? Then we can actually find the dl dx, and finally we can find the dl dt, right? So we are going to differentiate the dl dx, which is 10 over 7. Okay, so and then we actually can use back the dx dt just now. So that means we just find dl dx times with the dx dt. Then we can find the rate of change of the L, which is so-called as moving tip. Alright, so that means we will take 10 over 7, which is dl dx. We will times with the 3.5, right? Okay, so 10 over 7 times 3.5. So the answer will be 5 centimeter per second. Okay, so that means 1 second is actually increased by 5 centimeter. Alright, so that is so-called moving tip of the shadow. So that's all my sharing on how to solve the question involving rate of change. And the questions are rather challenging, but I'm sure you can do it if you keep on practice. Till then, bye bye and have a nice day.